This was the last of 4 graphs that we were doing. Okay, now I just want to get across to you, whoopsie daisy, just how mind-blowing it is to me, okay, that you can take these 3 factors and depending on how you combine them, the things that you get are wildly different. Okay, they're wildly different. But because of this underlying pattern of how the factors behave and therefore what signs they produce, despite how different all the graphs are, and we had a look at them, right? They all have this same kind of skeleton underneath that they all follow, okay, which I think is awesome. This is the last one, okay, and in some ways it's the weirdest, trickiest one, but you can get weirder. Let's have a look at it. We've already factorized it. There is no symmetry to speak of. We're up to asymptotes now, okay? So, which asymptotes are generally easier to get? Which one do you go for first? Okay, we'll go for the vertical ones because you can literally just read them off the denominator, right? So when you see the denominator is x plus 1, that tells you the vertical asymptote is x equals negative 1. Excellent. So, there it is right there, okay? Now, at the same time, you think, okay, do I have a horizontal or do I have an oblique asymptote? Now, we're trying to compare the degree of the numerator with the degree of the denominator. Degree of the numerator is 2, and therefore bigger than 1. So what kind of asymptote are we going to have? An oblique asymptote. Okay, now, so that we don't get too bogged down, I'm just going to show you what the asymptote is right now because I've already calculated it, and later on after we've looked at the shape, I'll tell you how to find what the oblique asymptote is. I also did the oblique asymptote in question 2 and we just sort of skipped over it, so I'll show you. Okay. In this case, the oblique asymptote is x minus 3. Okay, so in order to make it look reasonable on my graph, you can see I haven't drawn it at a 45-degree angle. That's not 45, but I'd have to make this graph very tall in order to get it really accurate. Okay. So we've got 2 asymptotes so far. Yes, x minus 3. So I've got x equals negative 1 and y equals x minus 3. Okay, and we will get into why that is the case in a second. Okay, case of mistaken identity. Now, after asymptotes, SFAI for intercepts. Okay, so what we're looking for are x and y intercepts, right? If I let x equal 0, that'll give me a y intercept, right? So when I let x equal 0, because I have x on the numerator, I just get 0, right? 0. So I'm actually passing through the origin. Right? That's kind of convenient because now when I work out my x-intercepts, that's my y-intercepts, right? When I work out my x-intercepts, turns out I've already got one. And the other one I read off the numerator, which is x equals 2. Bam. There we go. Okay, so now we have all the pieces. We have the asymptotes, we have the intercepts, we've already got the regions there. So where can this thing go? Alright, so for instance, let's have a look at this particular space up here. Okay, this particular space. Now, this space where my hand is, I can rule this out. There's no way the graph can go in here, right? I can't approach this asymptote from the top. Why not? Why can't I go there?
Oh, it goes into the section.
Yeah, that's right. So I would have to, to come here, I'd have to go up, right? And I've got a problem because I have a vertical asymptote, and vertical asymptotes can't be crossed, right? They're about domain and restrictions, so they can't be crossed. Unlike horizontal or oblique asymptotes, you can cross them as many times as you like because they just have to do with the extremities. Okay? So therefore, I can't come up this way. That means I must be under here. Okay, which means if I've got these 2 asymptotes to stay between, there's not much else I can do but that. That's all it can do. Okay? So I've got that branch. That's nice. And I guess if I want to point for scale. So what I would do is I'd put in, this is minus 1. So I guess I'd put in minus 2, which we can quickly compute this, right? Minus 2 times minus 4 will give me positive 8. And then I divide by negative 1. So that'll be negative 8, won't it? Okay. So there's my point. I'll just, negative 2, negative 8. It's approximate, okay? Just as we noticed before, there is a turning point there because it turns around, but we don't know. We don't have sophisticated enough stuff to work out where that turning point is. So I'm just going to put it there close enough. All right, now, let's see what's going in here, okay? I'm obviously going to come down from here because I've got this vertical asymptote to approach, okay? I have to hit this intercept, I've got to come down, I've got to come back to another intercept, and then I have an asymptote to approach, right? So what shape are you guessing? How would you describe it? Yeah, okay. It's almost kind of the opposite of this, right? All hyperbolas have a kind of symmetry, even if it's not like precise symmetry. So this is what I'm picturing, right? It's coming down, hitting there, and then it's approaching that asymptote over there, okay? It's a weird kind of shape, but you can kind of look at it from here and you can see that symmetry there, just barely, right? So this is different again. We've looked at all these different combinations. Sometimes you cross the horizontal or oblique asymptote, sometimes you don't. Depending on, I could put these all in the denominator and I'd get another graph again.